Hello, this is my AP Physics extra credit video. I'm going to be talking about a concept in Unit 1 kinematics, and the focus of the video is going to be on how vertical and horizontal movement and motion are independent of one another. For example, if you have a tennis ball that you hit 100 miles an hour in a straight line horizontally, and then you drop another tennis ball from the same height, both tennis balls will reach the ground at the same time. In other words, you hitting this tennis ball, this horizontal motion going so fast has no effect on when the tennis ball is going to hit the ground, because the force of gravity is the same on both balls. It's 10 meters per second going towards the ground.
Go.
So if you have two tennis balls here, one of them I'm going to drop from the height of the table, and then one I'll be rolling off the side of the table, and they're going to land at the same time, even though this one has horizontal motion on it. So we'll see here, it's going off, I drop them at the same time, and they land at the same time.
Go.
Alright, so if you have a plane that's traveling horizontally at 220 meters per second, that's about how fast planes travel, and you need to drop a supply drop to someone down below. Let's say there's someone who needs supplies, right? So when you drop this, the plane is going to be moving this at the same speed as this supply drop at this point here. So the supply drop is, if we're neglecting friction or air resistance, then the plane and the supply drop will be at the same place until the supply drop reaches the ground. So if the plane is traveling at 220 meters per second, and we want to know how far the supply drop will go, this distance here, from this point, then first we need to calculate how long it'll take the supply drop to hit the ground first. So to do that, we use one of our kinematics equations. D equals V naught T plus 1/2 AT squared. So D is this vertical distance. So here we're solving for the vertical time it takes for the supply drop to get to the ground. So this we're given here is 300 meters. The initial vertical velocity is 0, since the plane is only moving horizontally. So this is going to become 0 meters per second times time, which just equals 0, plus 1/2 AT squared. And then here I'm just going to erase this for space purposes. We have 300 meters equals 1/2. Then A here is the acceleration due to gravity, and that's going to be -10 meters per second squared. Then multiplied by time squared. That's what we're solving for. So -10 times 1/2 is going to equal -5 t squared. And then you divide -5 over on both sides. And that's going to give you, I'm going to continue over here, -60 equals t squared. And then actually this distance, since it's going down, this distance is going to be negative. So then if you're dividing by negative, this would be a positive 60. So t equals radical 60. And that equals 7.7. And so that's the seconds that it takes to reach the ground. So then we have this horizontal velocity. We can use the formula v bar, which is the constant velocity, equals the horizontal distance over time. And so this supply drop is going to travel for it's going to keep traveling until it hits the ground. And so we're given this initial velocity is 220 meters per second. We're solving for distance, and then time we calculated over here to be 7.7 seconds. Now here you cross multiply 220 times 7.7 seconds, and your horizontal distance comes out to 1,694 meters. So if you want to give a supply drop to this person here, you should release it when the plane is 1,694 meters away.